Very much for these kind words, for the invitation to present some of my recent research to you and your colleagues and your students. So welcome and thank you for your interest in this work. So I'm glad I have this opportunity. Of course, I'm looking forward to, at some point, also meet people in person in Ankara and visit Ankara. But maybe this has to wait for some better times. So, but in the moment, I can tell you what we are doing research on. And in fact, the work that I'm presenting was pretty much also concluded during Corona times. It was done also across the channel with a very fine colleague, was Klaus Ritzberger, who was a founding member of the Vienna Graduate School of Finance here in Vienna. And who is now actually at Royal Holloway in London. So we keep that contact doing research despite Brexit. So the ideas of research cooperation, of course, survive all kinds of political turmoil. The question that we are actually addressing is sort of a very basic question. So the talk is about intermediation and price volatility. And as you'll see, I'm talking particularly to fast markets because in current market microstructure, the technological developments we see actually, if I may say loosely, we see the valuation auctioneer in action, right? So those of you who have an economics background, they know that market equilibrium is determined by this valuation auctioneer who is matching demand and supply. But of course, you know, this is a parable. It's not really, it's a fiction, right? And of course, market microstructure has started to understand the process of price discovery and price determination. And by real intermediaries, I mean, how would real intermediaries actually set prices? And now this literature on foundation of valuation equilibrium is a pretty dated literature. It's 40 years old. I mean, this is what I did during my PhD, right? and likewise Klaus. So, but of course, in recent times, trading technologies allow trading by even by the nanosecond, right, at very high frequency, and actually these fast markets, you might think the faster markets are, the closer you get to some sort of continuous trading, and you're getting closer to the textbook paradigm of valuation price determination in markets. So basically, this fast trading gets rid of all frictions, but in fact, it turns out the opposite is true. When trading, when individuals, when actually not individuals anymore, when algos, when computers trade, when fast computers trade against each other, then of course, at the end, frictions become very strong. And I mean, this is what we find. So just to motivate my talk, let me give you this picture. Now, this is a Journal of Finance paper by Skilko and Sokolov, and has a great title. Clouds reduce price volatility. What does that mean, right? What does weather have to do with volatility in securities prices? Well, actually, you see New York and you see Chicago, and you know, for trading between the derivatives and the underlying securities, derivatives are basically traded in Chicago, or the stocks are traded in New York. Well, of course, if you want to hedge positions, if you want to actually do trading, if you want to benefit from information and so on, of course, you want to be very fast, and you trade with the fastest technology. Now, the standard technology that until a few years, the fastest technology was glass fiber, right? Fiberglass technology. So I mean, on linear connections, and that's what you can see here through the Alleghenies. You know, you see basically the route, which is a linear route, and of course it's a very fast route. But then microwave transmitters have been, did allow for even faster transmission of information. So actually, billions, actually dozens of billions of dollars were invested for introducing this faster transmission technology. And apparently there were intermediaries. There were firms investing in this high-speed technology. And now you have a choice. When you are in New York, you want to trade in Chicago and vice versa. You have a choice which to use. And of course, market participants choose the fastest one. Now, the only problem is if there are clouds in the air, if there's bad weather, then microwaves, they don't work well. They cannot communicate anymore. So they are down. So you're down to glass fiber, right? And this is a lot, well, it's not a lot slower, but it is a little slower. And the empirical evidence is whenever there's bad weather on this direction, on this line between Chicago and New York, actually price volatility goes down. Or put it differently, whenever the sun shines again and trading can be faster, price volatility increases. Now, this seems odd, right? I mean, how can we explain that? How does weather affect the volatility of prices that are determined in securities markets? So this is the question. This is a phenomenon, right? And actually, this phenomenon, I mean, it's basically, portrayed in a very stark way in this paper. This is a purely empirical paper, but there's a lot of other evidence of complementary evidence that faster markets are not necessarily, better markets in the sense that price volatility is reduced. You basically get a better deal in faster markets. No, in fact, actually, it's more risky because price volatility increases. So you have to hedge against price volatility for trading those markets, right? So you have to be aware of that. And of course, the question is, why is that so? And well, we are not offering the full story. We are just trying to identify one basic element, which is actually ultimately linked to the notion of price competition in markets. So yeah, here's some other evidence that is sort of supportive, which is actually motivating our question, right? Böhmer Fong, they find in a recently published paper in GFQA, actually it's published 2021, and they show that in faster markets, non-fundamental volatility has increased. Fundamental volatility is just, news-induced volatility. Prices change when there is more news. So yes, you would expect that faster markets allows to introduce news more easily, and maybe that's a contributing factor. But even if you allow for control for news, then you still have non-fundamental volatility that is also increasing, right? And that's their paper. And then there's our other evidence. The recent paper by Jovanovic and Menkvel that was published in GPE this year. In an early version, they were looking at Belgian and Dutch stocks, and they found a very similar result. Unfortunately, it's no longer in their paper for whatever reason, but that paper also found that an increase in trading speed is associated with higher price volatility. Okay. So how does the speed of price setting affect equilibrium, right? This is the question that we want to address in a very basic model. And does that make any economic sense? And what might be the underlying problem, right? And yes, maybe I should say that right away. We are not relating to information, right? If you think about private information, so we are really interested in non-fundamental volatility, right? It's not that information, sentiment, data are communicated more quickly. No, we are not taking this route. We are not saying this is unimportant. This, of course, might add, but even in the absence of fundamental volatility, we ask the question, how speed of price setting affects equilibrium outcomes, right? Now, just very generally, I mean, I understand not all of you are economists, so this is a very interdisciplinary group. So let me just say a few words about economics. Intermediation, of course, is a very central activity, but it's an activity that has been, very much under-researched in traditional textbooks and in traditional economics. It has come to the fore of interest in the late 80s or 1990s with a new field called market microstructure. And the name already shows that the microstructure of the price setting process and so on became a centerpiece at that time. But otherwise, intermediation still is, it's fair to say, it's fairly under-researched. They're basically, standard macro models, for example. If you do economic policy, you are interested in macroeconomics and macro policy. Typically, models with supply and demand are used. And, there's a notion that wherever they intersect, these might be particularly stable points. These are equilibria. So we can use these equilibrium prices to predict essentially our market outcomes, and we can predict how drivers of demand or supply, policy variables, taxes, what have you, how they might affect market equilibrium, right? So, but the process per se is not really modeled that much. Now, models of decentralized trade were developed in the 1980s. The idea is saying, well, no, markets actually work a little bit like a bazaar. You have buyers and sellers, and they match. There's some sort of random matching, and they negotiate prices. And then you have price dispersion, because in different matches, different people come out with different agreements. So there is nothing like a uniform price. You have price distribution, price dispersion. Now, price dispersion is a little bit of a problem because, as in math finance, you would say, well, if you have different prices, then you can apply arbitrage, right? And you can arbitrage all pricing differentials. Well, this is true in a model of centralized trade, but it's no longer true if you have personal prices, match-specific prices, right? And of course, on a bazaar, it's very difficult to arbitrage bazaar prices relative to organized prices, right? So these are, I'm just mentioning this, these are two different approaches. And of course, there is very famous literature, going back to Douglas Gale and Ari Rubinstein and Asher Wolinsky, who actually establish under which conditions decentralized trade in the limit actually converges to these centralized outcomes. So there's something like a micro-foundation of these macro models by some market microstructure models based on decentralized trade. Now, basically, that's also what we are going to do. We want to do basically some sort of centralized trade, and you will see we'll actually categorize buyers and suppliers by demand and supply functions. But we want to actually have intermediaries, price-setting intermediaries, who intermediate between buyers and sellers. So these are just merchants, they are buying the product and they are selling it on, like on the fish market, right? And the dealers on the fish market, they buy the fish in the morning, and then on the market, they sell it to their customers. So these are typical merchants, intermediaries. And in a sense, these dealers in securities markets are doing something very similar. They purchase the securities that they sell on later. Of course, in fast markets, there might be timing issues. Sometimes they sell securities that they don't yet have, that they only will get a little later. So basically, they short sell securities. But the idea is, of course, similar, that you intermediate between buyers and sellers, and you do that for a profit. This will be sort of the standard workhorse model for our model as well. What is special about this type of models is that we do have two-sided competition. Now, if you think about the fish market, the merchants, of course, compete in the morning for the best fish that they can sell at the highest price in the afternoon, right? Well, maybe I should say it differently. In the very early morning, they buy the fish, and then later in the morning, they sell the fish. Of course, by lunchtime, typically fish markets are closed because of sun and so on, and conditions. But you get the idea. There is competition on the input market for the product that can be sold on the output market later. So we have two-sided competition. This will also be an important element in our market. And we will also actually think about time in a very structured way. We will not think about markets taking place in continuous way, but like the fish market, as batch trading. So we will have different periods in which trading takes place. So of course, you can say these trading periods, they converge to nil, they become very small. So the trading periods can be 1 nanosecond, but a nanosecond is not 0 nanoseconds, right? It's still a discrete number. So we can have very high frequent trading, but in discrete time. That will be important for our setup. And we can then ask, how would outcomes in this discrete setup converge, if at all, if the time becomes smaller, right? If you have more frequent trading and so on. In our study, we also abstract from many other effects of intermediation. So the intermediary doesn't add any value, right? Doesn't inspect the fish or refines the fish or whatever. So it's just pure intermediation. It's pure merchant activity, buying and selling. And we will provide game theory analysis, a strategic analysis. So the traders actually act strategically. They trade for a purpose. They want to earn income. They want to maximize profit. And they do this in a strategic way, right? So these traders in these fast markets, if they invest in this high-speed technology, they don't invest billions of US dollars for nothing. They do it because they strategically want to achieve some advantage. They want to profit from these investments in the trading business. So of course, these are strategic decisions, right? This is important. And so we need basically a game theoretical setup to actually discuss the equilibrium strategies. Now, the strategies that we will look at will be investment strategies into some trading technology. And then, of course, also price setting. The quoting of prices will also be strategic, right? In order to then profit from the trading technology. So, yeah. Ultimately, we want to ask the question, how does speed of price setting affect equilibrium outcomes, right? Right. Now, let me get back a little bit to the literature. I already mentioned there is this literature on centralized trade, and there's this literature on decentralized trade. I already mentioned Rubinstein, Wolinski, but there are others who also worked about the relation of strategic price setting in bilateral matches in a search and bargaining framework. And they analyzed how outcomes in such decentralized trading environments, how they relate to our equilibrium that is generated in valuation markets, in markets in which some fictitious valuation auctioneer clears the market such that demand exhausts supply, right? This is the typical centralized model in which the valuation auctioneer is not really modeled, right? It's a fictitious auctioneer. The decentralized trading models try to actually replace this fictitious auctioneer by real world dealers, merchants, or what have you. So here are a couple of papers that actually show that centralized trade might not be innocuous either. So the one paper that is very important for us as well, there are two papers here that are very important for us. The one is Butters, because they generate very similar results in a different context. And the paper by Stahl. Stahl basically analyzed the fish merchants that I already mentioned. So when the merchants in the morning, basically buy fish and then compete in the afternoon to sell their fish, obviously there are strategic issues. If you, as a merchant, buy all the fish that was caught that morning, then on the selling side, you're a monopolist. So you might actually overbuy. You might just buy a lot of fish, even if you don't want to sell all that fish, just to preclude your competitors from getting access to the fish and then trying to compete against you on the selling stage, right? So you can think of situations in which actually replacing a valuation auctioneer by competing intermediaries will not generate valuation outcome. It will actually generate some sort of valuation monopolistic outcomes. and there may not be simple equilibria. Of course, there might also be situations in which you have competition between traders, in which they compete. There are many of them, say they compete in the morning, so everybody has a little amount of fish, and then in the afternoon they sell that fish. So, and in that sense, if they are basically on par, competing on par, you will get pretty close to variation outcomes, right? That might also happen, but it's not obvious. It's not obvious that price competition per se will generate variation outcomes. Actually, the two-sided nature of trading means that at the buying stage, you can define the capacities from which you sell on the selling stage. Now, if you purchase all the stock available, you are monopolist on the selling stage. If you purchase 2/3 of the stock, you only leave 1/3 to your competitor, you still are in a comfortable position. You have market power relative to your competitor. So it means that you can at least sell some of your fish at a higher price than the competitor, and you profit from that, right? So competition on the second stage, on the selling stage, will depend on the outcome of competition in the buying stage. And it's all but clear that this is always, zero profit equilibrium, that you always get a well-determined price. In fact, you might end up in heterocycles, and you might get some sort of mixed equilibrium. Name is missing here on my list, but heterocycles might actually be pretty close to what we get also in our result. Now, okay, there are also papers then on intermediation which are similar to ours, or in some sense, they basically make the point that intermediaries are active, strategic intermediaries do affect market outcomes. I won't go into this literature because I would rather like to tell you what we are doing. And you might come back if you are interested in one or the other paper later and how it relates. But I think in the moment, I don't want to confuse you with too many other papers. I actually want to tell you what we are doing. Right? So let me introduce now our paper. Right. Maybe I should emphasize we have two methodological contributions. The way we model fast trading is actually taken from the contest literature. And actually what we are modeling are contests with unknown number of contestants. Most of the contest literature is actually deals with the case of a known number of contestants. So the competitors know how many competitors are in the market, and they derive the results in pretty straightforward games. Now, the main result that we get depends on giving up on that assumption. In fast markets, you never know whether you are the fastest. If you quote, right, and you're competing against many other algos. So there are many computers out there, many competitors out there that might actually send quotes to the market. There's a certain probability that if you have a very fast computer, you are the first with a quote. But there might be a chance that you're already second or third, or there might be a chance, at low probability that actually several contestants are active at the same time. So basically, you never know, how many competitors you have. And this is basically equivalent to a contest with unknown numbers of contestants. Now, this is the key assumption that is driving our results. Okay. Okay. Maybe let me give you briefly the model, and let me then give you an intuition of what's happening here, right? So that you get the structure, and then we can go through the details in more detail. The model is highly stylized. And we are basically looking at two commodities. One is money, and the other is the asset that is traded. So think of it as a stock, right? It's a particular stock. It's one asset. So it's really a very simple word. And we have two intermediaries. Now, the two will be important for part of the analysis. In principle, of course, you could think of a large number of intermediaries. Our analysis is actually, at the end of the day, done for two, for reasons that I explained to you. But we could, the basic insight does not depend on two. The formula, the complexity of the model depends a lot on two. I mean, three will be a lot more complex and so on, but the main result will be the same. And we have we have two intermediaries. So there is potential competition between these intermediaries, and we have a large number of regular agents. You know, these are investors buying or selling this asset, all that good. Intermediaries only care about money, so they only care about trading profits. They are risk neutral. The regular agents, they care about the underlying commodity or the security. So that's what they want, right? For whatever reason, they don't like, when they care for the commodity, right? They are endowed with money and commodities, but they want to adjust their commodities. They want to buy more of the commodity or want to sell some of the commodity. So they care about the position of the commodity. Intermediaries don't care for the position. They don't consume that, the dividend or whatever. They don't want to hold that commodity. They only care about money, trading profit. Now, the regular agents, they are represented by standard aggregate demand or supply. For similar reasons, as we know it in economics in general, or the optimal plan given a market price is described by demand function or by demand correspondence. And likewise, the supply of that commodity is determined by a supply function or a supply correspondence. So that can be multi-valued, then we call it the supply correspondence. We assume that the intermediaries have deep pockets, so their budgets don't matter. I mean, these are large intermediaries. These are intermediaries who can actually buy or can afford to buy high-speed technology. So they have to have deep pockets because this is a very expensive technology. So they have unlimited endowment in money, but they have no endowment in the good. And after all, they don't care for the good. They don't like the good in the first place. They don't consume it. They don't need it. The only reason they have it in their inventory potentially is because they want to trade it. Okay. So each intermediary, this is where we will start thinking about speed. Each intermediary also can acquire a type. And this is just loosely saying the intermediary can trade early or late, right? And this is the type. Now, this type that an intermediary can obtain will depend on the investment in the speed technology. If you don't invest, you will never be able to be of type 1. But if you invest, you can make it into type 1. If you invest a lot, the probability of actually becoming a fast trader increases a lot. That's the idea. And of course, each of them can do that, right? So the type determines whether you move in period 1 or in period 2. Right. Now let me give you a little bit of timing. And again, the timing is very stylized. The idea is initially the intermediaries, these are large intermediaries, they can invest in speed technology. So they will invest resources, Y, into a speed technology. Now, well, for that investment Y, they need a cost, Ci of Y, that's a convex cost, and it affects the probability of being fast, right? I mean, of course, whether you really, whether this technology pays off or not, will, among others, depend on the investment of the competitors. So, given all the investments of all intermediaries, these investments determine who is going to actually be active in stage one, in the fast stage, right? So these investments determine a probability measure that then precisely tells us who is going to be fast and who not. Right. I will say a little bit more about the structure of this probability measure. Yes, that's the idea. I mean, the investments determine basically the probability of being a fast trader and being able to quote your prices early or not. So, yeah, if you're in the fast segment, right? If you turn out to be actually an early intermediary, then what can you do? You can actually you learn whether you are fast, but you do not know whether you're the only person who is fast, right? It could be that you and somebody else is also fast. So you are actually competing. Now, what you can do is you can now offer an ask price or a bid price. When you do that, you are possibly the first one to announce that price. And if you do that in the fast market, there will be a segment of fast consumers who submit also a demand or supply offer. If you are the only one, if you are the only merchant in market, you will be matched against them. So basically, you can buy at the bid or sell at the ask. However, there's a certain probability delta that you actually deal with early buyers. There's a probability gamma that you deal with early sellers. And then there may be a probability that actually none of the buyers and sellers arrives in the early market. Then, of course, you have been fast quoting prices, but it is of no value because there's no demand and supply. That may also happen. I mean, this is just logical possibilities. But of course, being fast means that you can actually attract early buyers or early sellers. And if you are the only merchant in the market, in the fast market, you have a monopoly position. Early buyers and early sellers, well, the only problem is the potential competitor. It might be that actually there are two, or in general, there could be more than two fast intermediaries. If they are lucky, that's a very rare event, but it could happen that several actually are fast. Now, if the fast buyers or sellers see different quotes in the fast market, basically their algos will be directed to the best prices. So they will go to the lowest ask or the highest bid. So that means if you managed to post a monopolistic quote in the fast market, if you are the only guy, then you will be able to profit from that quote by exploiting early buyers or early sellers. However, if a competitor also managed to be fast, and if he undercuts you by a couple of basis points, then he will get all the business and you are out of the market, right? So this provides price discipline and is an argument against charging monopoly prices in your fast, because you might be undercut. Okay, right. So this is happening in the fast segment, right? Now, after the fast segment has closed, then the intermediary ends up with a position. Either you purchased some of the security or you sold some. Then you basically, if you didn't have any inventory, then you are short of that security. And then you have to go to the slow market. So this next stage would be the slow market. And at the slow market, the residual demand and residual supply will enter. And of course, also the intermediaries with positions will enter to actually close their positions. So this is the slow segment, or that's period 2, that's stage 3. And this secondary market then basically is a completely competitive market. And here the idea is that this market operates a little bit like a valuation auction market. So basically here we have patron competition, we have competitive pricing. This is pretty much the type of price determination that you have, from mass finance, right? The valuation auction type prices that are determined by competition. That's because all relevant actors are there, and there is no capacity constraint, so we don't have this patron actuals type issue. So all supply will find its demand, and there will be a market clearing price. And this also allows dealers who took up a position in the fast market in period 1 or in the early stage, they can now unload their position in this market, right? Okay. So, right. To explain a little bit what I just said, if basically at stage 2, an early buyer did arrive, and aggregate supply is SP, then aggregate demand is basically the demand of the early buyer plus the remaining demand that basically then arises in the second market. A is the lowest ask price. It's a fast intermediary with the lowest ask price, because this guy will get all the buyers, the early buyers, and these intermediaries will now. This intermediary was lucky, who actually got this demand, will now exert that demand on the secondary market, because he has to buy from the supply. He doesn't have an inventory, so he has to buy from the second market. So basically, in the secondary market, you have this demand of the intermediary, of the winning intermediary in stage 1, plus the market demand, right? And likewise, if there was a sale in the first stage. Okay. Now this is the slow segment, and yeah. Right. So basically, at the second stage, yeah. Basically, we can now work out the equilibrium prices in the markets in case there is demand, and or I mean, if there's an early buyer or a seller, we can work out equilibrium prices, and we can actually also work out the profits, the revenues that the winning intermediary will actually earn in stage 2, right? So we can work out by comparing the ask price to the winning to the equilibrium price in the next stage, or similarly for the buying price. Now, okay, I have to tell you a little bit about the payoffs. Yeah, the intermediary, the winning fast intermediary, what will he win? I mean, I already said. I mean, he will basically he will ask the price A, but in order to be able to sell these securities, he will himself have to buy on the secondary market at the equilibrium price of the secondary market, which will now be PD of A, which of course depends on his own position times the demand, right? And he will only profit by the price differential from the fast buyers, right? So this is the profit that he earns in case he's lucky. If he's unlucky, well, he won't get any demand in period 1 and or period 2, and therefore in the primary market, and therefore not in the secondary market either. So if he gets 0 revenues, you know, then of course it did not pay off to invest in the technology, right? And there's a probability of that being possible. Now, likewise, of course, you could have an early seller rather than an early buyer. And then, of course, you get the same profit now on the other side of the market, right? Now you benefit from the seller. Now, how are the probabilities of winning determined? This is, of course, now quite crucial. And this is where we now basically employ some technology from the contest literature. So basically, we have certain investments are in stage one in this investment technology, and they allow us to calculate the probability measure of winning. Now we have to basically specify the probability measure, the probability of being fast, which is mu I, and once we specify this probability measure as a function of the investment, we can work out conditional probabilities that you are actually, once you are fast, that you are actually the only person in the market. So the conditional probability that a fast intermediary faces precisely one competitor in stage two can be worked out, as a conditional probability, yeah. Okay. At this point, I apologize. I have the general notation. Ultimately, we only are interested in one intermediary. So I guess in the next slides, this will be simplified. So we don't need this very general notation. PI is the probability that you are basically the only winning intermediary. So once you are fast and you are the only one, this will be the probability in which you face basically an empty set. But then there's also probability that you are actually, once you win the race, that you are actually also matched with your competitor, that the competitor might also be there. So this is another conditional probability that you need to be worried about. If you don't make it into the fast stage, then of course this conditional probability is zero. Then they have no chance of exploiting this monopoly position. Okay. P star is the equilibrium price, the valuation price of the underlying demand and supply structure. So this is just sort of taken from the standard paradigm. Now, what are the assumptions? What's driving our results? We have demand and supply functions, which are very standard, twice continuously differential, strictly decreasing. So basically, these demand and supply functions are convex, and we also assume that the residual supply and demand functions are concave. Cost functions are twice continuously differentiable, strictly increasing convex. Basically, what we want to assume here is we want at the valuation stage unique equilibrium. So we use all the assumptions to actually have a unique valuation price to get rid of all the other problems that might arise if you have multiple. So we basically buy all the assumptions that we need for a unique equilibrium. Now, here comes the part of the contest literature. We assume that these are effectiveness functions, Fi. Well, we assume that these conditional probabilities are now, or these probability measures, they are actually a function of the investment in the technology, right? So mu I y1, y2 is the probability, or is a measure of intermediary I that he will actually, win the race, that he will be basically the winner. Now, this depends on his own investment, but it also depends on investments the intensity, if you like, of his competitor, plus the joint investment of both. Now, basically, there are three outcomes of the investment stage. One outcome is that I becomes the winner, or the other, J, becomes the winner. So basically intermediary 1, intermediary 2, or it could be two intermediaries. We assume that the outcome that none of them wins actually doesn't, the probability of that is 0. So we assume basically mu, we specify mu such that this doesn't happen. Because we just rule out uninterested cases by doing so, right? There's nothing interesting happening in that case. So that's what we assume. But we assume that there is a possibility that both intermediaries are actually active. And this causes all the problems. That's what I said. Well, no, if nobody invests, of course, we will have measure 0 of being fast. Of course, you have to invest something in order to be actually able or eligible for fast trading, right? So this is a way of modeling these probability measures analogously to the contest literature. Now, these functions f, well, they look like an intensity function or an effectivity function. But if you ask me, how can you come up with such functions? This is actually the model of Dixit of 1987 that we generalize by allowing or actually ties or allowing two winning bits, right? So basically, this equation 2 is the innovation over Dixit that we introduced to allow for the fact that actually it might be that two fast traders actually are active at the same time and are effectively actually competing against each other at the fast stage. Okay, this is the crucial assumption. So having mu naught of y1 and y2 positive distinguishes us from the standard contest literature. And it's the basis of the results that I want to show you. Okay, now I give you the whole overview of the timing of our game. The game is very stylized. Initially, intermediaries invest in the speed technology. The speed technology determines who is going to be allowed in the fast market, the primary market, right? It could be one intermediary by assumption, or it could be two. Now, let's concentrate on the case of duopoly. If we have more intermediaries, of course, you could think about a richer structure. But in duopoly, we only allow one or two intermediaries entering stage 1. And by assumption, we exclude the possibility that there's no fast trader, because that's not an interesting case. It just gives us back the old traditional results in which basically this fast period doesn't play a role. Okay, now the interest of the paper is really the strategic behavior of these fast traders in period 1 in the fast market. Now, once the fast market is settled, the outcome is determined. Well, the intermediaries, the winning intermediary of stage 1, plus all the residual demand will be matched in the secondary market in a very traditional way, right? And then we get back to standard results. So all the action is in the primary market. Yeah, I already mentioned we have the assumptions that I showed you before. We assume basically everything that we need to guarantee that duration options generate a single price, individual price. Okay. Importantly, as you can see here, if the conditional probability that an intermediary, once he makes it into the fast stage, that he's the only one. So the probability that he's the only competitor, so he's basically monopolist, if that probability is 1, then we have, again, a simple model in which actually in stage 1, we have a monopolist. And then in stage 2, the monopolist unbundles his position and we get basically the duration outcome of the residual game. So this is pretty much similar to Stahl, the paper that I mentioned before. So there is nothing new. All the interest arises when actually independently of your investment in stage 0, you can never guarantee the probability 1 of being the monopolist in the fast stage. If there is a remaining probability that the other competitor might actually be faster than you, or then actually the strategic game changes completely its character. And that's what we are after. So basically, we are interested in the second case. And I think this is very good. It's very descriptive of fast markets, because in fast markets, that's what we see. I mean, there's sort of also delay occasionally by a couple of nanoseconds or maybe even microseconds because of technological glitches and so on. So you can never, just for technology reasons, you can never guarantee that you are the first one. Think about the clouds example that I started with. If there are some clouds in the air, you know, you might think you are first, but in fact, if you are second, because there was a cloud in the communication, right? So there are these type of randomnesses in the technology that, despite all your investments, you cannot control. So we think that this case of PI less than 1 is a very realistic one, is a very descriptive one of these fast markets. Okay. Now, yeah, let me, okay, time is running short very quickly. So I have to speed up on the fast markets. Let me briefly say, yeah, what can we say? I mean, if we solve that game, I mean, if we solve that game, we of course do that by backward induction. We calculate the evaluation equilibrium price for given, you know, prices from the primary market. Then we determine equilibrium prices in the primary market. And then we analyze the optimal investment positions of the intermediaries. We do that for duopoly or for simplicity, or basically, or just to tell you the nature of the results. What we find is for this case of high-speed trading, we won't get pure strategy equilibria. So equilibria are that in bids and ask prices that the intermediaries quote will be mixed prices. So we will always have price distributions. We will have uncertainty, and this is what we call volatility. So in equilibrium, intermediaries will randomize. We will never get a pure strategy equilibrium for reasons I will explain in a minute. But of course, the probabilities of winning do depend on the prior investment. The more you invest in the beginning, the more likely you will be the monopolist in the competitions in the primary market, but you can never secure a monopoly position despite or whatever you invest, right? So I mean, you cannot guarantee a monopoly, but you can affect the probability. And the equilibrium prices will be mixed prices. That's saying that you know, you get price volatility. In the case, in the standard cases, you know, PI equal 1, you would get pure strategy equilibria. The contest literature has pure strategy equilibria, and the variation story has a pure strategy equilibrium as well. You don't have price volatility, right? There is no price volatility whatsoever. Now, this price volatility is related to the fact that you are never sure how many competitors you have. Now, to make that point, let's think about the monopoly in the primary market. Well, if you are, I mean, this is the nice case in which you actually are the monopolist. If you are the monopolist in the primary market, you are the single winner. Then what you can do is basically you quote a monopoly price, a monopoly ask price, a monopoly bid price, and then you exploit profit in a profit maximizing way your monopoly position, right? So you make a very strictly positive profit. Now, these prices, they distort the variation price. So either you have early buyers or you have some early sellers. And accordingly, the outcome at the primary market will be either AM or BM. So there will be trade either at the bid or at the ask. Now, this is the position. This determines the position that the fast intermediary has when the secondary market opens. So in the secondary market, you have the residual demand plus the position of the intermediary. They will now trade and they will clear in a valuation fashion, but they will distort prices. The equilibrium price in the secondary market will no longer be, you know, the valuation price, it will be either distorted upward or downward, right? Depending on whether there were early buyers or early sellers. Okay. Now this is monopoly, and monopoly is, is not compatible with Bertrand competition, with standard competition. We know that, and that's what we find here as well. What happens if actually this probability is less than 1? Well, if the probability is less than 1, well, there's no Nash equilibrium in strategies. So this is our strong result. Why? Well, imagine that there's a small probability. You're the monopolist. There's a slight, almost a monopolist, but there's a slight probability that I enter the market, right? So I didn't invest that much in the fast technology, but I have a small probability of actually being in front of you, because at the time you wanted to trade, there was a cloud between Chicago and New York, right? So I, for some reason, made it. Unlikely, but I made it, and I was faster, or at least we are at the same time. Now you ask your monopoly, ask and bid. Now I could say, well, you are so confident of your monopoly position that whenever I make it, I actually want to be sure that I get all the demand or all the supply in the market. So I could guarantee that by undercutting you by some basis points, very few basis points, and then I will get all the demand or all the supply. And then I will get almost the monopoly profit, a little less than you, but I take away all the market from you. Now this is bad news for you, because in that case, my undercutting reduces, of course, your revenues, and in the long run, you cannot even pay your investments. So you cannot afford to ask monopoly prices all the time. So you might also worry about undercutting. Now you might think, well, I undercut Thomas Gehrig's prices. Now, and of course, I might think the same way, but where does undercutting stop? Undercutting stops at the valuation price. And if we charge the valuation price, both of us will make zero profits. Now, you might reconsider, if we are back at zero profits, how can I pay my initial investment in the fast trading technology? And actually, I'm actually in the market more often than Thomas Gehrig, so I can take the risk and actually charge a higher price. So yes, so basically I'm telling you the story of deviations from any proposed pricing equilibrium. From any proposed pure strategy equilibrium, you will find a profitable deviation. So I basically walked you through the proof, just in words. There will not be a pure strategy equilibrium, right? There is no Nash equilibrium. That's what our first proposition tells. So the question is, of course, if there's no pure strategy equilibrium, what will there be, right? And yes, we can actually show that there will be a mixed strategy Nash equilibrium. Now, establishing the existence of a mixed strategy equilibrium is not that straightforward as in most of the game theory textbooks, basically because we have discontinuous payoff functions. So we can show that actually in our duopoly, we can work out this mixed strategy equilibrium. We have a way, we have a strategy to actually generalize this existence proof for mixed Nash equilibria also to more than 2 competitors. But this is very involved. This is very complex, and that's the reason at the end, to be fair, why we actually do that paper only for duopoly. Establishing existence for the case of 3 competitors is pretty tough. Even though we know the construction principle, it's very complex to do that, and and we haven't cleanly basically established it yet. But we are pretty sure of how to do it. The important part is, for duopoly, we show that actually a mixed strategy equilibrium exists. And right. I can give you an example, I guess. Here we have basically a simple example of the distribution functions for a strong intermediary who invested a lot, and a weak intermediary. So we basically see this distribution functions, and we see that the strong intermediary has an atom on some of his monopoly profits. Yeah, I have to speed up, right?
Yeah, I mean, that will be nice. We have another 5 minutes maximum.
Yeah, I promise maximum, right? Let me stop the example. Let me just highlight the main takeaways from our analysis. So basically, we have what our analysis shows in the case of duopoly, and that generalizes, we're pretty sure of that. There's a very fundamental trade-off. Either we have monopoly of the fast intermediary, and then we have distorted prices in the secondary market because of monopolist intervention, or we do have price volatility. We don't get a pure strategic equilibrium. This is always the case in which a PI is less than 1. We have price volatility as an outcome of that pricing game, right? So competition can somehow mitigate price distortions, but cannot completely eliminate them, right? Because you have this price volatility, you have endogenous risk in the market price. So there's a fundamental trade-off, right? And it's saying that faster markets are not necessarily better in the sense that they provide lower distortions. No, you buy lower distortions, at the cost of higher volatility. And of course, volatility is a different type of distortion. It's not a strategic distortion, but it's it's related to the trading technology. It's a technologically induced distortion. Okay. The important, or let me briefly talk about the last stage, investment stage. How do the firms invest in the high-speed technology, and basically how do they determine the whys, the investments, and therefore their probabilities? And there are basically 2 results. If we get back to the case that it can never be that there are ties, if we exclude ties, well, actually, then there is a unique equilibrium for strategies in which both intermediaries invest positive amounts. This we can show. However, the whole point of our paper is that we want this probability to be positive. And when it's positive, actually, things become more complicated. Now, in the symmetric equilibrium, we show that basically we get a vertical structure. One intermediary invests a lot, the other intermediary invests little. The intermediary who invests in a lot gets a lot of higher profits, and the other one gets lower profits. Now, in the case that we are interested in, essentially with the possibility of ties, we get a pretty similar result, right? So even here we can say, the one thing that we have, we get another non-existence result. We actually show that there is no symmetric equilibrium in strategies at the investment stage. So there's another source of uncertainty. However, the mixing strategies have properties that are pretty close to what we saw in the pure strategy equilibrium. Here I have some examples of showing you the best reply functions for the investment stage. And what you see in this example is actually an example that it might happen that there's no equilibrium. So here we don't get any mixed strategy equilibrium. We might get one equilibrium that has the structure or the properties of our pure strategy equilibrium, but we might also have several equilibria. So so there are lots of interesting things that can happen. But again, there's extra uncertainty and, if you like, volatility induced by the investment stage. Okay. So, to the extent that fast trading cannot guarantee permanent monopoly, a fundamental trade-off exists between flickery market power and the incentive to actually undercut temporary rivals at each instant. We have strategic price volatility. generated by the high frequent interaction in price competition. In equilibrium, both intermediaries actually earn positive revenues. And this is also a reason why, as long as equilibrium exists, both, of course, invest positive amounts. Okay. If there's equilibrium, equilibrium is always asymmetric. So one intermediary investing more than the others, but the smaller intermediary might also win occasionally, right? And investments typically are inefficient. That's what we can say. We are not making a point on whether there's excessive investment in high-speed technology or not. We cannot say that, but we can say that aggregate investment is clearly not efficient in that simple model. So probably in a more complex world, it's even less likely that these investments are efficient. So thank you very much for your interest and your patience. I hope I didn't take too much time of your question time.
No, that was right in the time. Thank you very much, Professor Gehrig. I just would like to ask first our participants if they do have any questions. If they raise their hands, then I can also make them co-host that they can ask their questions. I'll just check. I guess there is no questions, but I just would like to ask, when we consider about the typical risk measures, like the value at risk to measure the, which is very much affected on the volatility, have you ever thought of if there would be an improvement on the value at risk or the conditional value at risk determination?
Well, I mean, the question is, how would you want to calculate it? I mean, basically, what this is showing is that it's very difficult to, find some sort of. I mean, it's clear what the equilibrium price is in our model, right? But because of this high-speed strategic interaction, those prices that will show up on the ticker, I mean, with some delay, they may actually deviate from whatever the variation equilibrium is by quite a bit. So, you cannot use market prices to, put it differently. The problem that we identify becomes larger, the faster, the trading is. And this means that this volatility renders any sort of market-based measures less informative.
That's true, you are right, especially in terms of the pricing, the heavy tail properties very much is going to be affected by. So that's trying to find the equilibrium price in terms of keeping all the other components like this supply and demand in charge. So that's very important because that's very much sensitive to it.
That's a good point, because thank you for asking this question, because so far we are so much fascinated about our prices that we didn't discuss that much about further implications, right? So we were much interested in pricing and investments, but of course prices are important signals, that's a very important implication that to make clear that prices lose that function in fast markets, or there is risk at least that they are losing that function, right?
Okay, so I would like to thank you, and I also would like to inform our participants that this talk is also published and the paper is available, which we are going to send the information afterwards to the participants. I would like to thank Professor Gehrig for his time and such nice talk, very much detailed in terms of all the modeling parts and also literature. Thank you very much, Professor Gehrig.
Well, thank you all, and I'm looking forward to see the faces behind all these logos at some time. So I'm longing to visit Ankara in real in the hopefully not too.
We will be very happy to have you, definitely. Thank you.
Thank you.